Welcome back to 30 minutes of problem solving a day, day 9. Okay, I don't really have much to say at the beginning. We're just gonna continue where we left off on 2012 EFMA. Make sure to like and subscribe, okay? If you guys keep wanting this kind of content, just make sure to let me know down in the comments and I will keep making it. But we will continue for the next few days at least, okay? We'll see if I do it after summer. I honestly don't know. But let us continue with question number 16. Let's do it. I'm pretty sad that we missed number 1 last time, but it is okay, okay? You just gotta move on. Oh, that's so sad. Okay, number 16. Inside of a cart that is accelerating horizontally at acceleration A, there is a block of mass m connected to two light springs of force constants k1 and k2. Find the vibration frequency. So, um, basically the acceleration shouldn't really matter, right? Because essentially, like, changing the frame of reference basically just shifts the equilibrium point of the spring. So it shouldn't actually change the vibration frequency. That basically rules out A and B, right? And then once you have two strings like next to each other, right, that are like in series, then there's a actually I guess they're more in parallel than anything, right? Because if you have like bro, voice crack, holy moly. Because basically if you like displace by x, right, this guy gets displaced by x and this guy gets displaced by x, so your resulting force is actually going to be k1 plus k2 times x, right? So essentially we just find the frequency. If you don't have that, like, if the frequency is just root k over m, right? So in this case it should just be E, right? Because that is if you replace the effective spring constant with k1 plus k2, and our answer is E. Very nice. 16E. Bro, I'm surprised I remember any physics, dude. I haven't done physics in so long, bruh. Okay, 17. Show below is the log plot for the datitude collected for amplitude. That's what I meant to say. Period of oscillation for a certain nonlinear oscillator. Okay. The relationship between period and amplitude is best given by. So essentially, it's saying log a times, or log a times. Okay, so what's the slope? So it's going from 7 to 3. That's 4 over 2. So the slope is 2. Dang, why is the... Okay, so the slope is 2, right? Is that right? Yeah. And then the y-intercept is 3, and that is equal to log t, right? So, given that, we could basically just take it to the power of 10, or 10 to the power of that. You basically get 10 cubed times 10 to the 2 log a equals t, and then this is the same thing as a squared. So you basically get 1000 a squared is equal to t, and that is a. Very nice. Alright, 18. A mass hangs from the ceiling of a box by an ideal spring. With the box held fixed, the mass is given an initial velocity and oscillates with purely vertical motion, okay? When the mass reaches the lowest point of its motion, the box is released and allowed to fall to an observer inside the box. Which of the following quantities does not change when the box is released? Okay. Huh. So, box is mass reaches its lowest point of motion. Okay, so the period should not change because of the same reason we said before. Actually, yeah. The equilibrium position just changes, right? Maximum speed might change. Height at which it reaches its maximum speed might change. I'm pretty sure that's what it's gonna be, right? Because essentially you're just changing where the equilibrium position is. So essentially your spring is like this, right? And your mass is like going around this equilibrium position. But once you actually take out, like, release it downward in the frame of motion, there's basically no gravitational force anymore. So your equilibrium position gets pulled up a bit, right? So but like the amplitude might still be big, is what I'm thinking. No, I mean the amplitude shouldn't be bigger because it's still like 1 half mv squared is equal to kx, right? Maximum height reached. So, I mean, if D is true, or which of the following did not change? Wait, oh, then are we just done? Isn't it literally just B because of the same reasoning? Should be B, pretty sure. Alright, B. Or is it amplitude? I'm pretty sure it shouldn't be amplitude because, why, why that? When it gets to the lowest point of motion, yeah, because basically when it gets to the lowest point of motion, then it actually moves the equilibrium position up, right? So its amplitude is going to be this massive thing, right? And essentially it's going to go from here to like twice that up. So that, yeah, okay. So everything makes sense. And maximum speed is at the equilibrium position, so that's good. Okay. 19. A 1,500 watt motor is used to pump water a vertical height of 2 meters out of a flooded basement through a cylindrical pipe. It is ejected at a speed of 2.5 meters per second, alright. What is the following closest to the radius of the pipe? So, the volume that's coming out of the pipe each second is equal to, like, pi r squared, it's circular, right? Yeah, times 2.5, right? So this is the volume that's coming out, and then if you want to find the mass that is coming out per second, you basically multiply that by rho, okay? And then, once you have, that is the mass per second, you want to find power in terms of that, right? So, your mass per second, and each mass has to go GH, right? Like, you gotta increase the energy of each mass by, like, GH, right? Or, yeah, so essentially every second you're exerting, like, mgh energy, kind of is the way I like to think about it. So you can multiply by 10 times 2, and that is equal to your 1,500. So if we just solve for r, we should get our answer, pretty sure. Anything else I am missing? 1/2 rho v squared, do we have to use that at all? Okay, let's see, so, no, I'm pretty sure you don't, so that should be fine. Okay, so we'll just plug this in. We get 1,500 over 20 over 2.5 over 1,000 over pi, and then the square root of that is approximately 0.01 meters. So it should be 1 centimeter? What? Okay, yeah, it's around 1 centimeter is what I got, so we'll go with that. 19 is B. Alright, one more before we check our answer. Number 20. A container of water is sitting on a scale. Originally, the scale reads M1 is equal to 45 kilograms. A block of wood is suspended from a second scale. Originally, the scale read M2 is equal to 12 kg. Alright. The density of the wood is 0.6 grams per centimeter cubed, and the density of the water is 1 gram per centimeter cubed. And essentially, it is lowered until half of it's in. Alright, so this is like a pretty straightforward one, I'm pretty sure, unless I'm trolling. So, oh, it wants both of the scales. Okay, okay. So this first guy is basically the downward force on the dude is 12 kilograms, right? So essentially we want it to be, okay, so now we just need to find the buoyant force, right? So the buoyant force is going to be when half of it is, so essentially the buoyant force is going to be bigger than the downward force, right? Or, okay, so we got our weight, right? So our mass is 12 kg, right? Then essentially you divide that by 2, right? That's how much is in the half of the volume, right? And then the weight of the water displaced is going to be like 1, or the mass of the water displaced is going to be 1 over 0.6, right? Because there's more water wait, what? We're trying to find the mass, right? Yeah, so for each mass of wood, there is more water, right? More mass of water, yeah. So, that is why you would do that. And then that gives you the mass of water that's displaced, okay? And that gives you an answer of what? So that's like 10. So that means the top one should be 2 kg, and then the bottom guy actually gets the inverse, like Newton's third law. It's the opposite, force downward, so it goes 10 downwards, and that would be 55, right? So our answer should just be E. Very nice. 20E. All right, let's check our answers. 15. Yep. Yup. Yup. Bruh. Did I? Oh no. Okay, okay. I will check that after. And yeah, that's right. Okay. What did I do wrong here? So, we got a 1,500 watt motor. Modernized. 1,500 watt motor. And then you got a vertical height of 2 meters. So 2 GH, right, times 10 times times 2, right? That's how much energy each like part of the water needs to go through, right? And then oh, do we also have to add in like how much speed it has at the end? Yeah, you probably oh yeah, okay. Yeah, you probably got to do that too, right? Well, no, that would decrease our radius though, right? Well, I mean, it probably doesn't make sense, right? So plus so 2 times 10. Wait, I already multiplied by the height. What am I doing? Okay, so you got 2 times 10 plus 1 half v squared, right? So that's like how much energy you need per mass, right? And then you gotta multiply by the mass per second. Okay, so that makes a bit more sense. You get like mass per second is 2.5 times pi r squared, and then this whole thing, and now we gotta multiply it by 1,000 kg, and that is equal to 1,500. Okay, so let us try that. Is that the right answer? 1,500 over 1,000 over 2.5 over 20 plus 1 half times 2.5 squared, okay, over pi. I'm pretty sure that would, wait, what? How do we get a different, oh, I guess, yeah, that, oh, I'm so, oh my god, I'm such a troll, dude. That is literally, that is 10 centimeters, god dang it. Bruh, I'm just bad at reading my calculator, oh my god. Okay, we knew what we were doing, okay, so that makes sense, alright. Bro, how did I make this too stupidest mistake I could possibly make? God dang it. Oh well, it is fine. Um, Number 21. A spring system is set up as follows. A platform with weight 10 newtons is on top of two springs, each with spring constant 75 newtons per meter. Okay. On the top of the platform is another one. Okay. There's a ball with weight of 5 newtons fastened to the top of the third spring and then slowly lowered. How much does the height of it change? Okay. So essentially it's just saying that it's not going to vibrate, which is why it says slowly lowered. So eventually, eventually there should be some equilibrium, right? So yeah, so the tension on this string got to be 5 newtons, right? So 5 over 75. This spring has to be compressed by 1 over 15, right? Meters. Okay, and then the force downward on this wood block is, okay, so the wood block has 10 newtons, right? So the downward force is also going to be 75, but, well, it's 75 plus the weight, right? So 75 plus, no, what? No, it's going to be 5 downward plus 10, so it's going to be a total of 50 newtons downward. So both of these springs have to push back up with a, okay, so they're putting together, so their effective spring constant is 150, right? So essentially each of those guys are actually going to be 1/10 meters depressed, right? So essentially, you just add the change in heights of each of the spring, because that's all that's changing, and you should get our answer. 115 plus 110, what is that? 1 over 15 plus 1 over 10, 0.17, alright. That's not even an option. Hold up. Bruh, hold up. So 5 newtons, right? And then you divide out the 75 newtons per meter, you get 1 over 15 meters, right? And then the platform has weight 10, so it has the force from the top spring downward, so that's 5, right? Then you got a total of 15 newtons downward, that makes sense, okay. And then we got two springs with 75, okay. So if each of them are by 1/10, then shouldn't that make it a total of 15 newtons upward? um, yeah, so each of these guys change by what? Height of the spring system. Okay, yeah, so it's the whole thing, right? So that means 115 from this dude and 110 from these guys, right? Am I not? What? Am I not? Am I trolling? What? 5.0 newtons. That's right? Okay, hold up. 1 over 15. That's 0.0667. So that's that. Or that, right? Huh. What? Oh, I feel like that should be right. how much time did we spend so far? It is 15 minutes, so we have a little bit of time. I'm gonna think about it carefully. But I feel like I'm not trolling, right? Okay, I probably am trolling if it's not an answer choice, but, come on. Really? So it had a 7, yeah, that's right. So if it's supporting a 5 Newton ball, it has to be compressed by that much, right? Otherwise, what? Let's think. Yeah, that's 1 over 15 for sure, right? I'm not trolling, yeah, that is 1 over 15. Then 50 over 15 newtons, right, is how much downward you got. And you gotta totally go upward 15 newtons, right? Huh. Maybe it's this? I mean, that's the only other option I could see. But why would it be like 1 over like 30? That would mean like this guy had the spring constant of that, right? Weight 10 newtons, okay. Yeah, okay, I don't get it. Oh, we'll see what it is, but huh. Yeah, okay, I'll just put D for now, and then we can come back to it and see if we find anything new. Alright, so 21D. The softest audible sound has an intensity of that in terms of fundamental units of kilograms. Oh, come on, dude, what? Bruh. Alright, so watt is like force times velocity, right? So essentially that would be kilograms meters per second squared, right? MA times meters per second over meters squared. This stuff cancels out, and you're left with kg per second cubed. Very nice. So 8. I like how 21 was kind of troll, and then you got 22, which is okay. 21 was pretty good, but 22, what the heck was that? All right, 23. This is why you don't like stay on a single question in FMA, because sometimes there are really easy questions in the last 5. Okay. Which of the following sets of equipment cannot be used to measure the local value of acceleration due to gravity? A spring scale, which reads in force units, and a known mass. Um, that's fine, right? Because you just divide by mass. You just literally put the the mass on the spring scale and then divide by stuff. Okay. A rod of known length and unknown mass. Okay, so there's another dimensional analysis one, pretty sure. So you got your acceleration due to gravity of meters per second squared. You want to find. So you got meters, you got mg, and you got um, and you got a stopwatch. So you got seconds, so that's fine. Not mg, you got kg. All right. Then the next one is an inclined plane. All right. The problem with this one is that you don't have any lengths, I'm pretty sure, so that's not going to work. Launcher, that different speeds, so you have meters per second, and you have mass, and you have meters, so that should be fine. Yeah, because you usually just shoot the projectile and then, like, measure how far it goes, right? Motor of known output power. A known mass and a... I'm pretty sure just be C, right? Because essentially just, like, looking at the... If you have, actually, kg meters per second. Yeah, so this should be fine too, because you have a mass, known mass. So it should just be C. Why are 22 and 23? If I get it wrong, then you guys can roast me, but I'm pretty sure I'm not trolling. So that should be fine. Okay, 24. 3-point masses M are attached by identical strings. When placed at rest on a horizontal surface, the masses form a triangle with side length L. Okay. Okay, so eventually they spread out. Okay, that makes sense. So basically, like, L is the equilibrium length of the springs, right? And then eventually they become 2L, so each of them is stretched by L. So essentially this is going to be KL this way, right? KL that way. And that is going to give you your that's going to give you your centrifugal what? Centrifugal force, right? No, what? I'm so stupid. Oh my god. This is why you don't want to like take a 5-year break from physics, okay? Centripetal, I know what I'm talking about. Oh god. Yeah, so centripetal force is going to be KL times like cosine of 30 degrees, right? So that is going to be KL root 3, right? Because it's 2 times that. Is equal to What's the formula for excel or force? It's like m r squared omega. Yeah, it's because v squared over r, and then that is the same thing. No, what? R omega squared. That makes a bit more sense, right? Yeah. Okay. M r omega squared. Okay. And then this just gets solved, and you get, what are you looking for? K. So K is just equal to mr omega squared over L. Oh, yeah, we could probably solve for R. So R is just going to be, if this is 2L, then if this is 2L, then this is going to be L, this is going to be L root 3, and then this is going to be 2/3 L root 3. So 2/3 L root 3 in the numerator, oh, L root 3 here. So you could just do 2/3 m omega squared. All right. C, epic. 25. Oh no, gravity. I hate gravity questions. This one we might not get, okay, boys? So just putting this out there. Consider the two orbits around the sun, alright? Orbit P is circular with radius r, orbit Q is elliptical, such that the farthest point B is between 2r and 3r, and that the nearest point A is between r over 3 and r over 2. Consider the magnitudes of the velocity of the circular orbit, okay? And the velocity of, okay. Oh god. So, I feel like this shouldn't be that hard, although it might be. Let's see. So basically the overall potential energy is like negative GMM over 2A, right? Where A is the semi-major axis, right? So essentially for V, your potential energy always stays the same. It's always going to be negative GMM over A, right? So your kinetic energy, or sorry, this is positive, right? Or no, it is negative. So that means your kinetic energy is always equal to GMM over 2A, right? And I'm assuming the, okay, so the mass doesn't really matter. So we only care about the first part. In which case, we basically just want to find where the kinetic energy is the biggest, right? So how far this farthest point B is between 2r and 3r, and nearest point is between r over 3 and r over 2. So that means the semi-major axis was the smallest one. So you could do r over 3 and 2r. So r over 3 and 2r. So that's like that. So our smallest one is probably going to be 8 over 3r, right? So, no, so sorry, 7 over 3r. Wait, what? Yeah, 7 over 3r, right? And then once we got our semi-major axis, that's this, right? Then our, let me see. So if it's closer, you have, wait, how does this work? Okay, hold up. So essentially you got your potential energy in this case would be negative GM M over like 2 times that, which is 14, so 3 over 14 A, right? Or R. And there's R over here. And then you want to subtract out your potential energy, which is GMM over R over 3, right? So that's at VA, right? So if we just solve this, we basically get, what do we get? Or minus negative. So it's like 3 minus 3 over 14, which gives you quite a bit bigger than this, right? That's definitely bigger than this, okay? And then over here at VB, okay, what was it? Calculate this out. It's like 42 minus 3, 39 over 14. All right. Then the other option is for VB, right? So that would be like, this is 3R, right? So that would be 1/3 minus 3 over 14, which is definitely smaller than this, right? So this is bigger than VC, is what we got. It's definitely bigger. Wait, what? So VA is the biggest. So VA should not, this doesn't work. This seems like it would work potentially. So first, for sure not these two. Right. Wait, what? Hold up. Yeah, so, yeah, when it's closer, it should be more. So, for sure not the first two, right? Yeah, because this is definitely bigger than 2 times that, alright? So, that is not it. That is not it. VA has to be above. Okay, 10 might be, right? 10 VB. So, this times 10, what is this? 14 minus 9 is 5 over 42. And that times 10 would give you 50 over 42, which is still not bigger than that. So that doesn't seem right. VC is greater. Okay, I feel like this is the right one. So this time root 2. 5 root 2 over 42. So that's like 1600. Okay, this is bigger than 1/2 though. 5 root 2. No, that's not bigger than 1/2. No way. Okay, maybe I'm just trolling. I hate gravity, dude, so much. Holy. How much time do we have? Okay, we have like 4 minutes, but we'll get this one before we're done. Am I trolling though? VA is definitely bigger than VB, right? Like, just by using your potential energy, you know that. So where else is, and it's like a lot bigger too. Oh, we did R over 2, so this should be 2R. Oh, so that actually changes things. So this is 1/2 minus 3 over 14. That would be 14 minus 6 is 8 over 28. And then if you do root 2, that makes a bit more sense, right? What is 8 root 2 approximately? So 8, that's 64 times 2. If you square it, that's 128. Root 128 is around 11. And that is still smaller than 1/2. Because like 1/2 is like how much VC is. Huh, I'm actually kind of confused. Let's see. So 3 over 14 plus 1/2. That's right. Pretty sure. Bro, I'm pretty sure I've done this problem before. I just forgot how I did it. Okay. I'm pretty sure this is the right way to do it too, though. That's a sad thing. R over 3, right? So R over 3, this would be 3 minus 3 over 14, right? Okay. Wait, no, wait, this is just, wait, yeah, okay, that makes sense, because it should be really big. Okay, so VB should be tiny. Oh, VB times 10, maybe. Okay, so, wait, actually, yeah, this might make sense. So 80 over 28. Oh, wait, yeah, that is bigger than, okay, so what is this? This is, what do we get? 39 over 14 times 2. 7, yeah, okay, it is, actually. Oh, so it is C. Alright, nice, nice. 25 is C. Alright, let's just go back to 21, just make sure we check it, and then we should be good. Cause I don't know, I remember really that troll. I seriously should know it, right? So, it's slowly lowered, right? So that basically means it's not gonna vibrate. And basically the top spring has to be, like, has to have a force of 5 newtons to keep it in place, right? So, if you got 5 newtons, and then it goes down by 5 over 75, like, meters, right? And then your bottom platform goes down by, like, 5 plus 10, right? Because, like, the spring pushes out the same on both ways, right? So if you got 15 downward, and your spring had to support 15 upward, then essentially you have, like, 15 over 150, right? Uh, I'm pretty sure that's right. I don't get it. Okay, let's just see one more time. I'm pretty sure, like, that's not even an option, though. 5 over 75 plus 15 over 150. Oh, God. Okay. Bruh. Big bruh moment. This is making me so sad. Okay, I'm just gonna go with D, because, like, that's the closest one to what I got. But that's kind of troll, not gonna lie. Alright, let's see. It's 1? Why does how tall this guy gets not matter? What? I am very confused, not gonna lie. Okay, whatever, it's fine. I will look at, what's the name? Kevin S. Wong's solution after this. So, this one's right. That's right. That is right. And that is right. Very nice. So let us just look. Kevin S. Huang. What is it? 2012 EFMA. Okay. This guy got all the epic solutions. 21. Okay. So F over 2K. Yeah, that's what I got, right? So F over 2. And what is F, though? Oh, so F is like the force exerted by these guys. But why is the force by these guys the same? What? Oh no. Yeah, I don't get it. Why does the force exerted by these springs have to be the same as the force exerted by that spring? Cause they're still like gravity. What? Okay, I'll just take his word for it. So basically, he's just saying that the force exerted by the two springs, or like all the springs, have to be the same. In which case, yeah, that makes sense, right? Um, so we would get like 0.67 over times 3 over 2. Yeah, that doesn't make sense to me. Whatever, it's fine. Okay, oh well. But anyways, that is what we got for you guys today. You guys did not want to see OBS. Okay, I'll just go to this as my backdrop. But anyways, thank you guys so much for watching. As always, if you enjoyed the video, make sure to leave a like and subscribe, okay? Because if you guys like the videos, I want to make more, right? So if you guys like it, leave suggestions in the comments, all that good stuff. Make sure to remember to do all the other stuff too. Comment down below. I don't know what else is there to do. Sign up for Carrara Courseware if you want to make me some videos. But on that, that's all I got for you guys today. Thank you guys so much for watching, and see you guys next time. Alright.